Hey, sixth grade, we finally get to a lesson that involves a shortcut, so we won't have to keep drawing out pictures for every single example. We are going to use an algorithm. It's a math shortcut to multiply whole numbers by fractions. But when you use shortcuts, you have to think about your answer. Does your answer make sense? Is it reasonable? Here we go. This is the algorithm or rule. It looks really super complicated, right? But let's take a look at the green words first. It says we can find the product, which is the answer to a times problem, of two fractions by multiplying the numerators together and then multiplying the denominators together, right? So let's take a look at what that looks like over here. Here's a numerator, A, and here's a numerator, C. Ms. Toivola, why are they using letters? Because the numbers in the problems would change all of the time. Maybe it'll be a 3 on the top in the first problem. Maybe it'll be a 5. Maybe it'll be really tricky and it'll be a 17. Because the numbers can change in math, that's when we use letters, right? So we're going to multiply the numerators together. So on top is A and C. So now we're just going to multiply A times C. That will give us the numerator answer for, that'll give us a numerator answer. And then it said multiplying the denominators together. So the denominators, they used B and D. And you'll notice in the answer, it says B times D. We're going to spend just a little bit of time for why this works, because I think shortcuts are neat, but I think it's more important that you understand the why. If we look at the first part here in blue, it says the product of the numerators will give you the number of pieces in the answer. And the product of the denominators will give you the number of pieces in the unit. Boy, that sounds really complicated. Let's look at an example to see if we can really see what this means. Here's the problem, 1/2 times 3/4. We already know that if you multiply across, just like I just told you, 1 times 3 is 3. Great. On the bottom, 2 times 4 is 8. Great. I know that the answer is 3/8. But I want to think about the reasonableness of this. So that means instead of thinking about this as times, I'm going to call this 1/2 of 3/4. Here's 3/4. I'm going to cover up this empty part. It's still the same amount of gray. We're going to cut this gray part in half. I'm going to split it right down the middle, and I'm going to color in the top half. All right, now I'm going to bring back that picture over here, and I want you to see that this is the same amount that's colored in. In both cases, it's 3. That is this numerator. And the 8 is the denominator. And it's easier to see the 8 here, but we could bring it back on this other example, and you can see that there still are 8 here. So for the algorithm, for the rule, we're going to multiply the numerators together. 1 times 3 is 3. 2 times 4 is 8. Right? And multiply the denominators together. Top times top, bottom times bottom. That's the rule. So going back to kind of that weird complicated thing, right, about multiplying the numerators together, and that gives you the product of the parts. All right, so here we go. You see up here that it says 1 times 3. When we are multiplying the numerators together, we're actually finding the area of the smaller part. We're finding the area of the 1/2. So I can see that this green is 1 tall. Let's grab a different color green. And it's 1, 2, 3 wide. So if I wanted to find the area of this part that's green, I could take the vertical number 1, it's 1 block tall, times 3 blocks wide. It has an area of 3. That is what's happening on the numerator. And for the denominator, when we multiply the denominators together, it's giving us the area of the whole shape, or the unit, this entire rectangle. So notice I already put a 2 vertically because it's 2 blocks tall. And if we count across, it's 1, 2, 3, 4. It is 4 wide. So if I wanted a shortcut to find how many blocks or how many parts are in this entire shape, I can do 2 times 4, and that gives me 8. And that's exactly what we're doing on the bottom. This shortcut is just telling us what we would draw if we were going to draw this entire part out. So we can solve these problems without drawing pictures every time, but it is important to think about the reasonableness of your answers. For example, students tell me this all the time. 5 times 3/4 equals 15/20. Does this student's work make sense? I can see that they said 5 times 3 is 15, and on the bottom, 5 times 4 is 20. Do you see how they got the answer, 15/20? But I hope that you remember back from our very first lesson in this unit that when we multiply with the whole number, it really means we have 5 groups of 3/4. We drew those also in clouds, right? We can also call them repeats, right? So here, I'm drawing 3/4. There's the first time, there's the second time. Here's 3 times 3/4, 4 times 3/4, 5 times 3/4. This answer doesn't possibly make sense. 15/20 can't make sense because we can start to regroup some of these parts. I'm going to color in one more on the front rectangle, and then I'm going to cross out that part here at the end. All gone, because I moved it to the front. I'm going to color in one more of the second rectangle, and then I'm going to cross out the next one. Right, and then I'm going to move one more, color it in, and cross this one out. Okay, so this is now all gone. What I see now is that we have 3 holes. 1, 2, 3, and we have 3 out of 4 in the last one. So this answer is really 3 3/4, which is way different than 15/20. So we really have to think, does my work make sense? So when we are going to solve this problem with the shortcut, here's what I recommend that you do. Don't leave this problem as just a 5 in front. I want you to change it so it looks like this. This is a crazy way to write the number 5, right? But let's just take a look across. We see 5 times 3 is 15, and on the bottom, 1 times 4 is 4. So that gets us to 15/4, which is the same as 3 3/4. So why, Ms. Toivola, can we do this? Right? Because 5 on top of 1 is a fraction. Its name is 5 holes because 1 is on the bottom, so that like a rectangle hasn't got split up at all. It's just one giant part, so that's a hole. You can also read that the same as 5 divided by 1, which is 5. So it's a really complicated, kind of strange way to write the number 5. But the reason why we do it is because this multiplication problem is really easy now. Let's do one more. 3 times 5/8 should be 15/8, but kids want to say 3 times 8, and they want to change this number down here to 24. But remember, that would just be an equivalent fraction. So instead, we're going to change 3 into this crazy fraction, which is 3 holes, or 3 divided by 1, which is 3. Then when we multiply across, 3 times 5 is 15, and the bottom 1 times 8 is 8. Your turn. In every single one of these problems on the practice page, there's a whole number. I think you should go through right at the beginning and write them all over 1. Then these problems become really stinking easy. Remember, you can work with a partner on this practice page. Check your work before you turn it in, and I'm pretty sure it's going to be in the green answer sheet by the door. You got this.